Hello everyone. So I hope everyone is that are very good and that in the safe zone only. Yeah, is better. So today we are going to learn that part 2 of that electrochemistry for that class 12. So in that previous part, that means that in the part 1, just I explained only the basic, only that foundation. Okay, that introduction, and we learn the few just the statements of that what is the electrolysis. Okay, and I explained that mechanism also, like the mechanism of that electrolysis, like at that cathode what type of the reaction is occurs, at anode what type of the reaction is occurs, what is the cathode. Okay, and what is the anode. Sorry, what is the cathode, what is the anode, and at cathode what type of the reaction is proceed, and at anode what type of the reaction is proceed. Hmm? And what type of that electrons can move towards this cathode and anode. And we'll learn the differences between the electrolyte conductors and the electronic conductors also. Okay, so now in the part 2 I'm going to explain about this, that electrolysis. Okay, first actually this the process I used means the statements and that everything, that note I'm already written better, so this is only for the course of to save the time, because that while explaining that notes on that paper, while writing on the paper, just we are having just I'm getting that so much waste of the time like that, and is the waste of that data also for you people. Okay, so if I apply this method, it would be that help for you to save the time for myself, and it can save the data also whenever I publish it in the YouTube. Okay, chalo beta. So listen to me. Electrolysis first. So this is the diagram about this, that electrolysis process in the previous part. In the part 1 I'm already explained. So this is the electrolytic cell, and this part, see better that here that the cursor is showing up like so the dotted part, this is nothing but that electrolysis, and this is the electrodes. These two rods can be noted as that electrodes, and these that electrodes can be connected with an induction, that means that battery. Okay, and I'm already told you like that one more thing, what is that, always that left hand side electrode can be known as that anode, and that right hand side electrode can be known as that cathode. Okay, at anode always what type of the charged species can move? Yes, according to that pronunciation, at anode anions can move, and at cathode cations can move. Okay, and generally we know one thing, what is that beta, like that if anions is contains that negative charge. Okay, where we know that the cations is contains that positive charge, isn't it now? So the positively charged ions is always can flow, otherwise it can move towards is that oppositely direction. So that means that if that cations, if it contains that positive charge, if they wanna move towards the cathode, then cathode should contain that negative charge. That's it, very simple. Okay, so the total phenomenon of whatever it is that the basic part of that electrochemistry, I'm already explained that part 1. Okay, just please watch it one more time. Okay, now electrolysis. Come to that part 2 of the first page, that electrolysis. So electrolysis of the two types beta. What is that? Non-electrolytes and electrolytes. And electrolysis again further subdivided into another two types, that is nothing but that strong electrolytes and that weak electrolytes. Now let us know that first one about that non-electrolytes. So the definition is already hidden in this word only. Non electrolytes, that means that not electrolytes. So what does that mean? The substance which do not conduct electricity, the substance which do not conduct electricity. See beta, here this is the electrolyte now. So suppose if any substance is taken here, like NaCl or HCl or H2SO4 or HNO3, like this, that any acid or base or salt, if it is taken in that electrolyte, if that substance, if not okay, it do not conduct electricity, even either it is in that molten state or aqueous solution state, then that type of the chemical substance, which type beta, those type of the chemical substance which do not tend to what, conducts that electricity through it, even if that solution is contains what molten state or aqueous state. That type of that electrolytes are known as what non-electrolytes. Examples beta, urea in water, no, it do not conduct any electricity, and some organic solvents and sugar solution, glucose solution, and non-polar covalent substances. Not the polar, non-polar covalent substances obviously can behave as what non-electrolytes. So these are the key examples. But one more thing, water. Water is a polar solvent, we know that. That means that charges are there. So charges are there means must and should it contains that electricity in a, but that pure water, it is a bad conductor of electricity. Okay. Now, let us know the second part. It is the very easy beta. Just suppose, so no need to explain this part. Just by watching the total notes, whatever I written over here, just by seeing also, just you people can get the notes yourself, and just you can get an idea about this one, and just you can easily get understood. Okay. Now let us go to the second part of the electrolysis. What is that? Electrolytes. So electrolyte, completely opposite of the definition of that non-electrolyte. In non-electrolyte, what happens with the substance which do not conduct electricity. But what about here? A substance, suppose if it is present in that molten state, otherwise that fused state or dissolved state. Dissolved state in the sense means what better? That substance should be dissolved in water, otherwise that any other solvent, where the water we know as like is the universal solvent, isn't it? Na? Water is known as what? A universal solvent. So a substance which it is present in that molten state, otherwise that dissolved state, if it contains that ions and that can act as, otherwise that function as that electrically conducting medium, that substance should behave as that a conducting medium. What type of that conducting medium? Electrical conducting medium is known as electrolyte. So generally all the fused salts like that sodium chloride, potassium chloride, otherwise that fused hydrides and solid hydrides. Hydrides are what? Silver, barium, lead, and alpha form of the Ag2S means silver sulfide. Okay. And aqueous solution of the sodium chloride, potassium chloride, and potassium sulfate or copper sulfate. So these are all the examples for these that electrolytes can behave like HCl, H2SO4, HNO3. These are the examples of mineral acids. But these are the mineral bases, NaOH and that KOH, etc., which is present in the water. So that's why these examples simply we can say as that mineral acids or mineral bases. Next, as usual, see beta, according to this table, what is that? Electrolysis again the two types, like that strong electrolytes, weak electrolytes. Very simple definition. Strong electrolytes means the electrolyte which should have that high conductivity. That conductivity should be very high, means that very strong. So that's why it can easily ionize that completely. So whatever the compound is taken in electrolytic cell, the total compound should be ionized completely. Why it is ionized completely? Because obviously it is having very high conductivity. So that type of that electrolytes is known as what? Strong electrolytes. Example same that mineral acids like that, like strong acids like HCl, H2SO4, HNO3, like this. Okay. Next, alkali and alkaline at the metallic hydrides, like that means first A group and the second A group elements of their hydrides. Like let us get the example of that alkali metals. What are the alkali metals? Better? Lithium, sodium, potassium, rubidium, cesium, and francium. Francium is a radioactive element, so just leave that. So the first year group elements, obviously, S block elements is nothing but the metals and their hydrides, sodium hydride, potassium hydride, lithium, sodium, potassium, rubidium, like this. So these are hydrides. can behave as a strong electrolytes, as well as that mostly of the salts can behave as what? Strong electrolytes. Okay, so this is the first page of the part 2 beta. So if you want to just, you can get the screenshot of this page. Okay, just a moment. Yes, now you can get the screenshot of this page. Okay, now go to the next page. Is the second page. So strong electrolytes we learn now. Next, weak electrolytes. Strong electrolyte ఏంటి బేట ఇక్కడ? What does it mean of the strong electrolytes? The electrolytes which have that high conductivity, then have the tended to ionize completely. Then weak electrolytes means that completely opposite. The electrolytes which have low conductivity and can not ionize completely. Otherwise, it simply we can say like can ionize partially. Anachu. Otherwise, it simply we can say as that it cannot ionize completely. See, yes, the electrolytes which have the low conductivity, which ionize partially. So examples for that weak electrolytes. What is that? The most of organic acids, bases, and the salts are the good examples for that weak electrolytes. See beta NH4OH, barium sulfate, BaSO4, HgCl2, okay, CH3COO, NH4, it's ammonium acetate, and boric acid. Do you remember all these that examples we learned in that class 11th of that acids and the bases chapter? Do you remember beta in the which topic? Buffer solution, I think, isn't it now? Buffer solutions, NH4OH can be has that uh, weak acid like that, isn't it now? Buffer solution basic logo, sorry, that weak base, and it is the salt of that strong acid is nothing but a basic buffer, isn't it now? So akkada chadukuna idi kuda ade beta salt. This is the salt where we will get the this salt with the help of that buffer solution reaction. So please do remember that acids and bases, that buffer solution. Okay, otherwise that just please refer once in that NCERT, then you can understand. Okay, what is the buffer solution, then you can understood this one. Okay na? So mostly most of that organic acids and the bases and the salts like this type of that examples can be as what? Weak electrolytes. Okay, now here I'm going to explain you that some important points to be noted here. And one more thing, so before going to explain, so please get the screenshot of this page if you want. Please get the screenshot now. Yeah, now let us continue. Yes, now let us continue some important points. First, let us know what is the electrolysis. Electrolysis means what? A process of what? Decomposition. See beta, so yesterday means that in that part 1 I'm already explained that briefly, like that suppose in this that electrolytic solution means in this water, let us suppose this is the water, in this suppose if I taken that sodium chloride, okay, so that can be taken as a chemical substance. If that chemical substance which is having the tendency to decomposition, okay, decomposition of what? Electrolyte. At what time it is going to be decomposed? Whenever there is that electric current. See here, just I'm showing that cursor over here. So at what time this that substance is going to be decomposed into its ions? Whenever the electric current is passed through what? This that electrolyte. Then that process, the process of what? The decomposition of an electrolyte, the presence of when an electric current is passed, that is known as what? Electrolysis. A total process named electrolysis center. Next, the cell in which the electrolysis is carried out is known as the electrolytic cell. So see beta, so this is the process is going over here. So this one, the vessel which it is taken for that electrolysis process is known as what? Electrolytic cell. Example for that electrolytic cell, yesterday I'm already told you that part 1, what is that? Galvanic cell, otherwise that voltaic cell. Okay, now next, In electrolytic cell means in this cell what happened, you know better, in that part 1 we are already learned what is that electrical energy is converted to chemical energy in electrolytic cell. But what about in that electronic cell? Hmm? Vice versa, reverse అవుతుంది, chemical energy is converted to electrical energy. Okay, next, what is that electrode? These are known as that electrodes now, means left hand side the rod can be that anode and the right hand side will be that cathode. Okay, so the medium through which the electrons are entered and leaves, that electrolyte is known as what? Electrode. So electrode మనం ఎలా డిఫైన్ చేయొచ్చు బట? The medium through. So this can behave as a medium. Okay, so from this medium, if the electrons is going to be enter from the one side and leave from that another side in the process, in with the help of what? Electrolyte. So that medium is known as what? Electrode. Next, come to over here. When a solution is contains two or more cations as well as that anions. See, suppose here we taken that magnesium chloride, suppose. Okay, instead of that sodium chloride, if it is taken that magnesium as well as that okay, I will give that one more example. Let us suppose if that left hand side, in that at anode, if zinc sulfate is taken, but the right hand side copper sulfate is taken. Okay, that means in this electrolyte, it is having the two cations as well as the two anions. Okay, then which of the metal is going to be deposited first? Here at the bottom of the cell, first, actually this that electrolysis process is carried for what better? For the extraction of metals. Okay, for the extraction of metals. So ikkada metal first edi deposit avutundi. Deposit in the sense means what? Like that akkada form kaavadam anamata. Okay, so when a solution is contains the two cations, otherwise the two anions, then the ion which is having that low discharge potential, that can be deposited first beta. Edaithe cation, edaithe ion ki low discharged potential untundo, low discharge potential, that can be deposited first. So see, first order of cations, this is the order of depositing. Okay, so first that lithium can be deposited first. First sodium, magnesium. See beta, suppose the left hand side, if that sodium chloride is taken and another one magnesium sulfate or magnesium chloride is taken. So here in this electrolyte we are taking the two electrolytes, like two substances. So here sodium is metal, means in NaCl sodium is metal, in magnesium chloride magnesium is also metal. So which metal is going to be deposited first? Means that sodium. Important point. Okay, and the same topic where we can learn in the end of the part of this the chapter, like that Ellingham diagram, very important. Pakka, the damn sure that objective questions will be given for the mains or that need point of view. So very important. Okay, and so this is the order better. So how can we remind this order? So this order is also should be reminded very easy method with the help of that one code word. Okay, I will tell you later about that code word clearly, but here just simply we can say that like that. See better that Leke Basri Khan Mughal Alauddin Mia Zikar take CD ko bajaye chapa chapa, like that something is there. Okay, and I will tell you later at the time of that electrochemical series. What is that electrochemical series? One topic is there which it is related to, like the same topic where we can learn that metallurgy, general principles of that metallurgy. There Ellingham diagram is there, not in that electrochemistry, sorry, in that metallurgy. So the same relation ఉంటుంది బట్ ఇక్కడ ఎలక్ట్రోకెమిస్ట్రీ లో ఉన్న ఎలక్ట్రోకెమికల్ సిరీస్ టాపిక్ కి మెటలర్జీ అనదర్ చాప్టర్ ఈస్ దేర్, అక్కడ కూడా ఎల్లింగం డయాగ్రామ్ అని ఉంటుంది. సో సేమ్ రిలేషన్ ఉంటుంది. సో అక్కడ చదువుకుందాం మనం. ఓకేనా? సో ఫస్ట్ ఈ ఆర్డర్ ఒకటి గుర్తుపెట్టుకుని ఏంటిది అది, when two or that more cations or anions are there, which is going to be deposited first? Tell me this one. See beta, so those ion is having that low discharged potential, then that can be deposited first. అంటే ఇప్పుడు లిథియం ఉంది, సోడియం ఉంది, దేనికి లో డిశ్చార్జ్డ్ పొటెన్షియల్ ఉన్నట్టు లిథియం కి, సో దట్స్ వై ఇట్ కెన్ డిపాజిటెడ్ ఫస్ట్. ఓకే, ఈ ఆర్డర్ కి కంపల్సరీ we should remind that order beta. So how can we remind that order? I will tell you in that next level. Okay, next anions కి కూడా ఇది ఆర్డర్ గుర్తు పెట్టుకోండి ఒకసారి. ఫస్ట్ ఫ్లోరైడ్, సల్ఫేట్, నైట్రేట్, hydroxyl OH minus, Cl minus, Br minus, I minus, and last CO3 minus 2. So this is the order of what? The cation depositing, not depositing, sorry, what is that? Deposited first cation anion, the order of cations. Okay, మరి order of deposition of cations అంటే ఏది డిపాజిట్ అవుతుంది ఫస్ట్? ఉల్టా చూడండి, దీనికి రిలేషన్ చూడండి, ఇది ఏముంది? So when a solution is contains two or that more cations or anions, then that ion with that low discharged potential. So this is the order of discharging potential. This is the order of discharging potential. దీనికి ఆపోజిట్ డిపాజిట్ అవుతుంది. అంటే సారీ బట్ ఇంతకుముందు నేను లిథియం, సోడియం అండ్ మెగ్నీషియం అని చెప్పాను కదా, నో ఉల్టా అనుకుంటుంది. అంటే దట్ ఫస్ట్ దట్ ఆరం Au+3 can deposited first. Okay, compared to sodium and lithium, sodium can deposited first compared to that copper+2 and sodium, which can deposited first copper+2 ala. Okay na, next anions ki kuda same, but ఇది order of deposition of anion. అంటే ఇక్కడ the order of anion, what is that order over here? ఏంటిది బట ఇది order? Discharge potential. బట్ ఇది ఏంటిది? డిపోజిషన్. అంటే డిశ్చార్జ్ పొటెన్షియల్ కి డిపోజిషన్ విల్ బి ఇన్ దట్ రివర్స్ మేనర్. దట్స్ ఇట్. అదొకటి గుర్తుపెట్టుకోండి. ఓకేనా? ఈ ఆర్డర్ ఎలా గుర్తుపెట్టుకోవడం అన్నది నేను ఐ విల్ ట్రై టు ఎక్స్ప్లెయిన్ యూ దట్ నెక్స్ట్ లెవెల్. ఓకేనా? సో దిస్ ఈస్ ద ఎండ్ ఆఫ్ the part 2 of that electrochemistry, and the next part where we are going to learn that very interesting topic, that is the Faraday laws beta. Faraday first law, Faraday second law, and we are having the numericals also. So very interesting topic. So don't miss the part 3 of the electrochemistry. And the Faraday law, this the IP means that board exam level. That board exams, that means that IP point of view is also very that important one. And depending upon the Faraday laws, the chances are there to be given the numericals. Okay na? So please revise once carefully the page 1 and that page 2. Okay, chalo then, bye bye beta, see you in the next part 3. Till then, have a good day and take care.